So now that we've connected the graph with the name of the function, we need to start looking at their equations and what are some of the important points, or we might call them critical points, on the graph. Eventually, what we're going to do is we're going to be able to transform these graphs. In other words, move them around the graph and be able to predict this based on what modifications we do to the equations. But again, before we do that, we need to know what the important points are so we know what exactly we are going to move. So our first function on here is our linear function. And again, our basic equation for that parent graph, again, no changes, no change to the slope, no moving the x or y intercept around. It's just y equals x. Now there's two critical points that we want to pay attention to. So first is, do we have a specific point that we can kind of follow along as we're moving these? And in fact, we have two of these. So we notice that our linear equation, our line goes right through the origin. And if we look at the next point up, so in other words, if we bump it up to x equals 1, the resulting y value for that function is 1. We have a point sitting at 1, 1. And so those are kind of our two critical points on here. We can also note the x-intercept and y-intercept because it's a great way to describe what's going on in the graph. In this case, our x and y-intercept both happen to be at the origin. So we're going to say 0, 0 for both of those. And we have that extra critical point at 1, 1. Okay, your absolute value, which is next. So that's our graph again. It looks like a V, comes to a very distinct point down at the center. And wait a second, you'll notice it goes at the origin as well. Okay. And so we also want to look at kind of the next point up. So if we move over to x equals 1 and kind of trace up until we find the next point on the graph, this one too, it has a point at 1, 1. Interesting. Okay, the equation for absolute value. Again, do you remember how you mark absolute value of a number? And that is actually your vertical bars on either side of that value you're taking the absolute value of. And again, for this, our x-intercept and our y-intercept both happen to occur at the origin. And you're going to see why I'm having you do x and y-intercept when we get to the later graphs. So I want you to make note of where those are for the different functions. Alrighty, next function, we have our square root function. Again, looks like kind of a little check mark. We hopefully noted last time that we don't have any negative values on here. Everything's in the first quadrant. We have it starting at the origin again, and lo and behold, we have another point sitting right at 1, 1 on the graph. Our equation for this, if we're going to take the square root, looks like square root of x. Our x-intercept and y-intercept, no surprise here, those are still at the origin. So 0, 0 for both of those. Is quadratic function any different? So he pretty much looks like the absolute value function. The only difference is it has a curve at the bottom instead of that distinct sharp V at the bottom, but it still has kind of its base point at 0, 0, and it still has another point at 1, 1. This is seeming to be a pattern here. Our equation for quadratic function, again, you called them parabolas possibly in Algebra 1. What exponent did we have in those equations? So indeed we have y equals x squared for our quadratic. And x and y intercept, guess what it is again? We are still at the origin. All right, these are the 4 big functions that we're going to use all the time. We're actually going to spend a decent amount of time on quadratics. We pretty much have 2 units on those that we'll be looking at during kind of the first half of this class. So these are the biggies. But we are also going to be looking at cubic functions and kind of what's related to them. So our cubic function, again, just like your quadratic function was an x squared, what does it mean when you cube something? So the function on this one, the equation is y equals x cubed. And again, just as a side note, don't forget, with all of these are functions. So what could we write instead of y equals and still be expressing a function? So again, don't forget, we could be writing f of x equals our equation rather than just the y equals. So that would be an option. Alrighty, so cubic function. Any difference in our critical points? We still have 0, 0. We still have a 1, 1. So let's pause here for a second. We keep having this x and y intercept being exactly the same number. We still keep having the graph go through that point at the origin. So what we need to do is start thinking about, well, what do these pictures actually look like? So I'm actually going to go back up to the linear function for a second. So linear function, we have a nice straight line goes right straight through those 2 points, the origin and 1, 1. So what's the difference between that and the picture for the absolute value function? Well, once we get to the left of the origin into our negative values, well, think about what absolute value is. It's that positive distance away from 0 on the number line. So that left-hand side of the graph, it's still going back up to the positive instead of continuing down to the negative like the linear function was. When we think about square root functions, again, when you take the square root of a number, can you actually take the square root of negative values? You're not going to get real answers when you do that. So you'll notice, again, no negative numbers on there, and kind of the overall shape, it starts at the 0 and kind of curves up past the 1, 1 and keeps going. Not going in a straight line, it is definitely a curve. Your quadratic function, again, almost looks like that absolute value function. And for quadratic function, it might not be a bad idea to look at the next point and look at how these are kind of symmetric to each other. So you have the 1, 1 point on the right-hand side. If I went over one more space over to 2, well, 2 squared is 4. And I have exactly the same pattern on the left-hand side. And so we're definitely kind of spacing out those next points. They're going further and further up, faster and faster. Your cubic function, however, you'll notice, compare that to your quadratic function. Quadratic function's all in positive. So what happens when you square numbers? Any numbers, you're always going to get a positive answer. Whereas when you cube numbers, so for example, if I was going to do -2 cubed, my answer actually comes out to be -8. So when you cube numbers, you will be getting negative values on there. So that's why it's almost as if we took that quadratic function and we just kind of flipped it around. So all the negative values to the left all ended up flipping down. Otherwise, it looks very similar to that quadratic function. Cube root function, again, we're taking the cube root. Again, I know you have not seen this function before. And we're going to explore this a little bit more too when we get to actually doing the cubic function. We'll be talking about that in the polynomial chapter a little bit. Right now, it's just enough to be able to recognize this. Again, you'll always have a graphing calculator, so you can always check what the picture of that graph looks like. If you don't have a TI calculator, don't forget we've got the Desmos calculator that you'll be able to use online. Same key points, but notice how it's curving a little bit different. So it kind of evens out going to the left and the right, unlike the square root function that just went up to the right. This one goes in both directions because we can cube negative numbers, so we can take the cube root of negative numbers. X-intercept and y-intercept, still 0, 0. Alrighty, rational function. So again, this is the weird one. I did give you a preview of this equation last time. This one's going to look like y equals 1 over x. So this is where we start differing a little bit. We do not have a point at the origin. And again, why did we decide that? What are the values that we can't divide by? So if you can't divide by 0, that means 0 is not going to show up on the graph. We do have other key points on here though. We have the 1, 1, and we have a -1, -1. But looking at our graph, does this actually have any x or y intercepts the way it's set up? Unfortunately, just the way that this parent function looks, I don't have any values. I can look at the ends of the graph though, and they're getting really, really close to those axes, but they're only going to get closer and closer and closer and closer, but they're never actually going to touch. So unfortunately, with this version, we do not have any x-intercepts or y-intercepts. But do you think we'd intersect the x or y axis if we shifted this graph up or down. So again, we'll talk more about that when we get to the rational functions unit. And then our last two, exponential and logarithmic. And again, these are related to each other. Our exponential function looks a little different. So this is just one example. So the graph that you actually have for your parent function here is actually y equals 2 raised to the x. So our variable is actually up in the exponent on this one. And so this one does have two kind of critical points on it. You'll notice it hits at the point 0, 1, but this one also hits at the point 1, 2. Because think of what would happen if you plugged a 1 into that exponent. So let me change my color real quick. So if I'm looking at y equals 2 to the x and I substitute in 1 for my x, so that would look like 2 raised to the 1. Well, what's anything raised to the 1 power? It's going to be 2. And that's how we come up with that value. So again, it's still following the function, but just because of the nature of that equation, it is going to look a little bit different. And again, if you follow this graph along, the left-hand piece of that keeps going closer and closer and closer to that x-axis, but it's never actually going to hit. So the way this exponential function is set up, the parent function itself actually doesn't have an x-intercept. Now, if we were to take this graph and shift it up or down, that would change. We do have a y-intercept though, and that's sitting at the point 0, 1. All right, our last function, again, this is one that you haven't seen before. We're going to be looking at this towards the end of the course. It's very closely related to exponential functions. This is called the logarithmic function, and we do abbreviate this a little bit. So if you look at a calculator, you might see a button that says log, L-O-G, and that's the way that we express this. So y equals log x. And with this one, again, you'll see it looks a little different from the other functions, but it is kind of like exponential, except instead of it getting really, really close to that negative x-axis, the part of our graph going down towards the bottom, it's getting really, really close to the y-axis instead, but it's never actually going to hit. So in this one, we have a y-intercept of nothing. It doesn't have a y-intercept. The x-intercept, however, it does cross the x-axis right at the point 1, 0. So think about which functions actually have that origin and 1, 1 as their critical points. Those are the main functions that we're going to start studying. That's pretty much the first half and a little bit of the course. So that would be functions like our linear function, our absolute value function, our square root, our quadratic, our cubic, and our cube root. But then when we start getting into some of these weirder looking functions, we don't have both the 0, 0 and that point 1, 1. We have to shift our thought process a little bit with how this is starting. So the ones that have something different, that's our rational function, our exponential function, and our logarithmic function. Alrighty, so our next lesson is going to start looking at how we can move these around. But for now, the main thing that you need to be able to do by the time you do your lesson check is just be able to match up the picture with the name, and then maybe state what X or Y intercept you see on that picture. See you next time.